Welcome back to the logical reasoning sessions. Today we will take a look at odd one out type of questions or classification type of questions. So what is classification or odd one out? I'm pretty sure you heard of this word many times, odd one out. A simple example or the best example that easy for us to follow is, let's say we have A, B, C and D. First one is lion, second one fox, then we have a cat, then we have let's say tiger. So here at a glance, what you see here? Lion, fox, cat and tiger. There are two ways of looking at it. First of all, lion, fox, tiger are these are wild animals, and cat is domestic cat, and we have wild cat as well. At the same time, lion, cat and tiger, they are from cat family. If they are from the cat family, then fox is the odd one. So there are two ways of looking at, and which is most logical? If you take lion, cat and tiger as wild animals, lion, fox and tiger as wild animals, then cat is the one which is different from the group. And if you take lion, cat and tiger as the animals from the cat family, then the fox is the one which is different from the group. So which one you think it's more logical? Fox, right? So these are the type of questions which comes under the category odd one out. So that pick the one which is different from the group. That's the meaning of odd one out. And we'll go for more questions from this category. Let's take a look at this one. And this is answer choice 4. So select the odd one, or select one which is different. Apple, guava, papaya, mango. These are all fruits. So 4 fruits, and which fruit is different from others? So apple, guava, papaya, mango. So what? Apple, guava, papaya, mango. So mango has only one seed. All other fruits, they have more than one seed. Anything else? Well, apple, guava and papaya, they are not juicy fruits. You cannot get the juice directly from these fruits over here. Well, you can get the juice through some kind of methods or some kind of process, but you cannot get it directly. But if you want, you can get the juice from the mango directly. So mango is a juicy fruit, and papaya, guava, apple are non-juicy fruits. So there are two different ways of looking at it. Even if you look at both ways, mango is the answer. Mango has one seed, and mango is a juicy fruit. Now this one here, what is it here? Mars, Saturn, Sun and Jupiter. So select the odd one. Mars, Saturn, Sun and Jupiter. So Mars, Saturn, Sun is a star, right? Sun is a star. All others are planets. So naturally, Sun is the answer. Now let's go for the next one. This is 11, 115, 10 and 90, 9 and 72, 8 and 56. What kind of pattern you get it here? 10 into 9 is 90, right? At a glance, that's what I see. 9 into 8 is 72, and 8 into 7 is 56. And how about 11? 11 into what? 11 into something is 115. Well, 115 is not a multiple of 7. That's the interesting part of it. It's not a multiple of 11. This case, this is n into n minus 1 pattern. You see that? N into n minus 1. This is n into n minus 1. And this is n into n minus 1. And in this case, 11 into n minus 1. 11 into n minus 1, that is 11 into 10, 110. But it is given us 115. So this one is the answer. Now we go for the next one here. 73, 47, 107, 231. So what do you see there? 73, 47, 107, and 231. So at a glance, you see that 47 is a prime number, 73 is a prime number, and how about like 107 and 231? 231, 2 plus 3 plus 1, so it's 6. So that is a multiple of 3. So that means 231 is a multiple of 3. All right. So fell 180. See that 180 is a multiple of nearest multiple of 3. We can remember 180. Then 210 is a multiple of 3. 210 plus 21, that is 231. So that is definitely a multiple of 3. So if that's a multiple of 3, you know what? These numbers are not multiples of 3. That's the only number which is a multiple of 3 is this one. All other numbers are prime numbers. That's the case. Now we go for, so the answer is 231. Now select the odd one. What is here? BEH. So it is plus 3. This is plus 3. So B plus 3. B is, position value of B is 2. This is 5. This is 8. So, well, B, 2 plus 3 is 5. 5 plus 3 is 8. Now CFI. CFI, this is 3, 6, and 9. So this is, let me write it this way. 3 here, 6 here, 9 here. So 3, 3 again. Now DGF. DGF, D is 4. This is 7. This is 6. So this is 3 and this is 1. I mean, this is minus 1. D plus 3 is G. G minus 1 is F. And EHK, 5, 8. Let me write it here. 5, 8, 11. So it is plus 3 again, plus 3, and this is plus 3 as well. So ultimately, what you get it here? Plus 3 plus 3, plus 3 plus 3, plus 3 plus 3. This one is 3 and minus 1. So this is the answer. Now, next one right here. Select the odd one. M, N, O, P. M, N, O, P. At a glance, we can say that, you know what, O is the only vowel in this group. O is the only vowel. All others are consonants. So O is the answer. Another one, the odd one. Square, circle, rhombus, and rectangle. Square, circle, rhombus, and rectangle. So square shape. Well, you know what is a square shape, right? You know what's a rhombus shape. And you know what is a rectangle as well. So which one is different in this case? Circle. Circle doesn't have the sides. All of the figures, they have sides. Four-sided figures. 4 sides, 4 sides, 4 sides. Circle doesn't have 4 sides. So circle is the answer. 94 and 7, 42 and 6, 35 and 5, 56 and 8. So what is it? 94 and 7, 42 and 6. So, well, it is 7 into 6 is 42. And this is 7 into 5 is 35. So, well, this number, the number on the right is multiplied by 7, you get 42. The number on the right multiplied by 7, you get 35. The number on the right, 8, it's multiplied by 7, what do you get? It is 56. So 7 into 8. So 8 is multiplied by 7. 5 is multiplied by 7. 6 is multiplied by 7. So now 7. 7 must be multiplied by 7. You need to get 49, but it is given us 94. So that is not the correct one. So all others are in a pattern. This is different from the group. So this is the answer right here. Now we have, okay, so this kind of questions, Directions for questions 36 to 40. In each of the questions given below, there are some statements which are followed by some conclusions. You have to take the given statements to be true even if they seem to be at variance from the commonly known facts. Read the statements and conclusions. Decide which of the conclusions logically follow from the given statements, disregarding the commonly known facts. So these type of questions are known as syllogism type questions. Probably you remember at the first session, we have taken a basic look at what exactly the syllogism type questions, right? So here the first question, all big are novels, some novels are willows, no willows are pencils. So many questions are from this area. So what we do, we'll take a look at the most simple questions first, then we'll come back to the other questions. So we'll go for the most simple questions. 42 onwards. This seems to be straightforward, seems. Then we'll go back to all other questions after this. All green are blue, all blue are white. Okay, so let's do the basic diagram. Let's draw the basic diagram. That's the first thing we have to do. Basic diagram using the statements. All green are blue, all green are blue. And all blue are white. So all blue must be white. Now, conclusion number 1. So we need to check whether conclusions follow the basic diagram or not. So well, basic diagram is based on the statements. So conclusions follow the statements or not. Some blue are green. Some blue are they green. Definitely, actually green, all the green inside the blue. So some blue are green. So first one, it's valid, it follows. Second one, some white are green. Some white are green. Definitely green is inside the white as well. So some white are green. So it's valid, it follows. Number 3, some green are not white. Some green are not white. What is that? Look at that. Some green are not white. Is it correct? Well, all green inside white. How come you say some green are not white? In this case, it's clear. All green are white. So some green are not white. It is invalid. If it is invalid, it doesn't follow. This is a negative conclusion. This is invalid. Doesn't matter. It's negative or positive conclusion. If it is invalid, it doesn't follow. Now, all white are blue. All white are blue. Look at this. All white. Are they blue? Well, all blue are white. But can you say all white are blue? No, not really. So all white are blue. It's invalid. So it doesn't follow. Now we have two conclusions which do not follow and two conclusions follows. So which are the conclusions follow? 1 and 2. So well, only 1 and 2 follow. That's the answer. Only 1 and 2. So that's the answer. Now we go for this one. All cats are vertebrates. Some animals are vertebrates. So all cats are vertebrates. We draw the diagram. All cats. Cats are vertebrates. Some animals are vertebrates. Some animals are vertebrates. Now you may ask a question, whether this cat is an animal or not. Well, cat is an animal, but according to the given statements, this is the way we have to draw the diagram. According to this diagram, cat is not an animal. That is what the diagram says. So there is no need to question that what is given in the statement. That is one of the major thing in syllogism. Do not apply your common sense. If you apply the common sense, the moment you apply the common sense, the question may go wrong. That's a peculiarity of syllogism. But in all other questions from logical reasoning, you have to apply your common sense. That's the difference. Now, that's a basic diagram. Now look at the conclusions. All cats are animals. All cats, are they animals? No way. There is no intersection between cats and animals. So all cats are animals is invalid. So it doesn't follow. A positive conclusion which is invalid doesn't follow. Which are the positive conclusions? All. All cats are dogs. And some. Some cats are dogs. And no conclusion. No cats are dogs. That's negative conclusion. Then some cats are not dogs. That's negative conclusion. Some not. So 4 standard statements. All cats are dogs, for example. That's a positive conclusion. Some cats are dogs, for example. That's a positive conclusion. No statement, no cats are dogs, for example. That's a negative conclusion. Some cats are not dogs. That's a negative conclusion as well. So in this case, all cats are animals. That's a positive conclusion. That's invalid for the basic diagram, so it doesn't follow. Second one, all animals are cats. All animals, are they cats? Not at all. So all animals are cats. Again, it's what? It's a positive conclusion which is invalid, doesn't follow. Number 3, some vertebrates are animals. Some vertebrates, are they animals? Yes, some vertebrates are animals. Perfectly all right. So that means that is valid for the basic diagram, so it follows. Now, number 4, all vertebrates are cats. All vertebrates are cats. Look at it. Vertebrates, cats. All cats are vertebrates. Can you say that all vertebrates are cats? Not really. All vertebrates are not really cats. So that means positive conclusion invalid, so it doesn't follow. Now, what do you see here? Only 3 follows, correct? Only 3. This one. Conclusion 3. Now, we'll go for the next question here. Number 44. All phones are scales. All phones are scales. And all scales are calculators. All scales are calculators. Now, all calculators are scales. All calculators are scales. That's the first conclusion. All calculators, are they scales? All the scales are calculators. Can you say all calculators are scales? Not really. So first one, it is invalid. Positive conclusion invalid means doesn't follow. Now, all phones are calculators. All phones, are they calculators? Well, look at that. All phones, that's inside calculator circle. So all phones are calculators. That's correct. Now, all scales are phones. All scales, are they phones? All scales? Well, all phones are scales. All scales are not really phones, right? So all scales are phones. That's invalid. Doesn't follow. And some calculators are phones. Some calculators are phones. What is that? Well, phones are inside calculators. So naturally some calculators are phones. So that is valid, follows. So this is what you have. We have 1 and 3 do not follow, but 2 and 4 follow. So we have only 2 and 4. So that's the answer. Next one, 45. All bats are tigers. Okay, so you may wonder whether any bat is a tiger or not. Well, no bat is tiger, but in this case the statement given as all bats are tigers. So we have to take that statement as true. We draw the diagram based on what the statement says. All bats are tigers. All bats are tigers. And all tigers are pigs. Now, conclusion number 1. All bats are pigs. All bats, are they pigs? Definitely. All bats are inside pigs. So all bats are pigs. All pigs are bats. All pigs, are they bats? All bats are pigs. But can you say that all pigs are bats? Not really. So this is again positive conclusion. Invalid, doesn't follow. Now some pigs are bats. Some pigs, are they bats? Definitely. Because some part of the pigs, it's bats. So some pigs are bats. Now some tigers are bats. Well, bats are inside the tigers, so naturally some tigers are bats. Some tigers are bats. So ultimately what you see here, 1, 3 and 4 follow. 1, 3 and 4. So this is the answer. And 2 doesn't follow. Now we have to go back to the questions we haven't touched so far. Which are the questions we haven't touched? 41, and the questions before 41, right? It's 41, then we have to go back. So let's go back 41, 39, 38, 37 and 36 onwards. Okay, so now this is what it is. All bigs are novels and some novels are willows. So we'll throw that. All big are novels and some novels are willows. Some novels are willows. These are willows. And no willows is a pencil. So willow and pencil, there is no intersection. So if for no statement, usually we draw a space arrow in between. That space arrow indicates this willow and pencil do not intersect. So this is pencil. Ultimately, that's a basic diagram. Basic diagram means diagram with a minimum possible overlap. Now we look at the conclusion. Some willow are big. Some willow, are they big? Is there an intersection between willow and big? There's no intersection. That means some willow are big, it is invalid. A positive conclusion, invalid means it doesn't follow. Number 2, some novels are pencils. Some novels, are they pencils? Absolutely no. This is pencil. So some novels are pencils. Again, that is invalid. Positive conclusion, invalid, doesn't follow. No willow is big. No willow is big. That's correct. There is no intersection between willow and big. So no willow is big. So it is valid. If it is valid, you know what? This is a negative conclusion. Negative conclusion is valid means we need to negate and further investigate. So no willow is big. When you negate it, what do you get? Some willow is big. Or some willows are big, doesn't matter. So we need to draw a new diagram based on some willow is big. So how do we draw a new diagram using some willow is big? Some willow is big. So this is willow, this is big. Some willow is big. At the same time, when you look at the basic diagram, what you see here, this big is completely inside what? Novels. Big is completely inside novels. And these novels are intersecting with the willows as well. So that means we have to bring in such a way that novels is completely overlapping the big, or big is completely inside novels. At the same time, novels are overlapping with the willows. Good. Now, willows are not really intersecting with the pencil. So we have to have that pencil as well. Pencil. So this is the new diagram we have. This is the new diagram. Now we need to check whether this new diagram, well, actually this new diagram is drawn based on the negated conclusion. So this new diagram is slightly different from the basic diagram. So now we need to check this new diagram exists or not with the given statements. So statements are all big are novels, all big are novels, that's correct. Some novels are willows, yes, some novels are willows, perfectly all right. No willow is a pencil. So, well, this case, pencil and willow, there is no intersection at all. So there is no intersection between willow and pencil. So this new diagram doesn't contradict with the given statements. If it doesn't contradict, new diagram exists. If the new diagram exists, that new diagram is based on what? Negated conclusion. So if new diagram exists, negated conclusion is valid. If negated conclusion is valid, the original conclusion is the negation of this conclusion, right? So if this is valid for the new diagram, then original conclusion must be invalid for the new diagram. Invalid. What is the original conclusion? No willow is big. So this case, some willows are big, right? So no willow is big. It is invalid for the new diagram. So that case, if the new diagram exists, that contradicts the given conclusion, original conclusion. So the original conclusion is invalid. So that means if a conclusion is invalid for at least one diagram, so there are many possible diagrams. We draw only the basic diagram and a new diagram using the negated conclusion. When you draw a new diagram using the negated conclusion, what you get is the diagram with the maximum overlap. This is the diagram with the minimum overlap, minimum intersection. This is the diagram with the maximum possible overlap. So this case, and there are many other diagrams as well. We are not supposed to draw all those diagrams. It is not practical to find out the answer for this question. Sometimes we may have 16 diagrams, 20 diagrams, 24 diagrams between these two diagrams. That means this is the minimum overlap, this is the maximum overlap. We may have many other diagrams possible. So we are not really trying to draw all those diagrams. But what we are looking for here, this conclusion is valid for one of the diagram. So that is basic overlap or basic intersection, it's valid, and it's invalid for another diagram. If this conclusion follows, it must be valid for all that possible situations. So always remember this. You may have this type of questions from different areas, symbols and notations, sometimes inequalities. So those kind of different areas you may have questions like whether the conclusions follow the statements or not. In order for the conclusions to follow the statements, conclusion must be always true. In different possible values of statement, conclusion must be true. And in this case, similar thing. Conclusion is valid at some point, conclusion is invalid at another point. So that means conclusion is not valid always. Conclusion is not valid always, it doesn't follow. So conclusion 3 doesn't follow. Now conclusion 4. Some novels are not pencils. So that case, in order to check the conclusion number 4, we need to look at the basic diagram. We don't need this new diagram. This new diagram is drawn for third conclusion. So we get rid of that new diagram right here. Now we look at what? Fourth conclusion. So what does this fourth conclusion say? Some novels are not pencils. So some novels are not pencils. Look at the basic diagram. Some novels, they are not pencils. That's correct. Actually, there is no intersection between novel and pencil. So in this case, we can, if we take some novels from here, they are not pencils. So if you take some novels from here, they are not pencils. So some novels are not pencils. So that is valid. Some novels are not pencils. It is valid. Let me use another color. Well, if it is a positive conclusion, if it is valid, definitely it follows. But this case, it's a negative conclusion. You see that? It's negative. It's a some not conclusion. If it is a negative conclusion, if it is valid, what you need is negate the conclusion. You need to negate the conclusion. How do we negate it? This is what some not conclusion, right? So when you negate it, become all. All novels are pencils. So, well, negation of no conclusion will be some conclusion, and no willow is big, negation of that would be some willow is big. And here in this case, some not conclusion, some novels are not pencils. Negation of that would be some not, negation of some not would be all. So, well, all novels are pencils. If all novels are pencils, we have to draw a new diagram based on all novels are pencils. So let's try that. All novels are pencils. All novels are pencils. If all novels are pencils, what is missing here? Well, we have big is missing. We have willow is missing. Many other things are missing, right? So we have to bring this big and willow, these two things, into this diagram. So let's draw that diagram this way. So this is novel. All novels are pencils. All novels are pencils. Now we know that big is inside novels. So big must be inside novels. So we have to, big must be here. Now willow. Willow is what? Willow is intersecting with the novel. Some willows are big. Sorry, some willows are novels. So we have novels here, then we have to have willow here. Willow must be intersecting with the pig. Sorry, pigella. Willows are intersecting with novels. So when willows are intersecting with the novels, you look at this. The basic diagram, willow is not supposed to intersect with the pencil. However, here this novel is inside, completely inside the pencil. If novel is completely inside the pencil, that means when the willow is intersecting with the novel, the willow has to intersect with the pencil. There is no other choice. So, that case, look at this new diagram, whether this new diagram exists or not. We will check it with the given statements. What are the given statements? All bigs are novels. All bigs, they are novels. Okay, that's fine. Some novels are willows. Some novels, novel and willow, there is an intersection. So, some novels are willows. Perfectly all right. No willow is pencil. Well, no willow is pencil. Willow cannot overlap with the pencil. But what you see here, willow is overlapping with the pencil. So, if willow is overlapping with a pencil, then this new diagram contradicts the given statements. So, this new diagram doesn't exist. If new diagram doesn't exist, that new diagram is drawn based on the negated conclusion. So, negated conclusion is invalid. If negated conclusion is invalid, then which is the original conclusion of this negation? This is the one. So, then some novels are not pencils. If this one negated conclusion is invalid for the new diagram, then the original conclusion must be valid for the new diagram as well. So, it is valid for the basic diagram and this is valid for the new diagram as well. So, what you get it from here, the conclusion, or what you can decide from here, for the basic overlap or basic intersection, this conclusion is valid. And for the maximum overlap, this conclusion is valid as well. So, if it is valid for minimum overlap and if it is valid for the maximum overlap, then it must be valid for all possible diagrams in between, if there are any diagrams. There must be diagrams, definitely, and it must be valid for all other diagrams. So, that case, what is it? If it is valid for all possible diagrams, then it follows. So, conclusion 4 follows. So, that is what we get it from here. So, ultimately what you get here, conclusion 1 doesn't follow, conclusion 2 doesn't follow, conclusion 3 doesn't follow. Now, conclusion 4 follows. Now, look at the answer choices. We have 1 and either 2 or 4 follow. And second conclusion says 2, 3 and 4 follow. Well, 2, 3 and 4, actually when we look at that, that cannot be the answer, because 1, 2 and 4 doesn't follow. I mean, that cannot be the answer. In this case only 4 follows. That means 1, 2, 4 follows means that's not the correct answer. Only 4 follows. Yeah, that is a possibility. Now 1, 2 and 3 follows. No, it is not. And in this case it says 1 and either 2 or 4 follows. 1 and either 2 or 4 follows. Does it like conclusion 1 follow here? Conclusion 1 doesn't follow here. Some willow are big, some willow are big, doesn't follow. So, that cannot be the answer. So, ultimately the answer is what? Only 4 follow. Only 4 follows. That's the final answer. Okay, probably we will come back to this question later. I have something else to discuss with you. And now we will go forward, then we will come back to this question number 36. So, now we will deal with the question number 37. So, what is it? Statement. Some people are nice. Some people are nice. Some people, they are nice. And at the same time, some foreigners are people. Some foreigners are people. These are the foreigners. And what it says, no foreigner is a Canadian. So, no foreigner is a Canadian means there is no intersection between foreigner and a Canadian. So, this is what the diagram we have. Now, we look at the conclusion. Some foreigners are nice. Well, some foreigners, are they nice? Not at all. There is no intersection between foreigners and nice. So it's a positive conclusion which is invalid, so it doesn't follow. Now, some people are Canadians. Some people are the Canadians. There is no intersection between people and Canadians. So it is what? It is invalid for the basic diagram. Some people are Canadians, invalid. So again, a positive conclusion, invalid, means doesn't follow. Now, some foreigners are not nice. Well, some foreigners, well, they are not nice. If you look at some of the foreigners, if you take some foreigners from here, they are not nice. If you take some foreigners from here, they are not nice. So that means some foreigners are not nice. It is valid. It is valid. Let me use another color. This is valid. However, this is negative, right? If it is negative, negative conclusion valid means you have to negate it. When you negate it, what do you get? Some foreigners are not nice, so some not diagram, when you negate it, that become all diagram. All foreigners are nice. So how do we draw a new diagram for all foreigners are nice? All foreigners must be nice. That's a diagram. However, we have people and Canadians are missing in the new diagram. So we'll bring it here. People is intersecting with nice and foreigners as well. So we have to bring that. People intersecting with foreigners. At the same time, people is intersecting with the nice as well. Now foreigners, no foreigner is a Canadian. That is what the statement says. So that is what we have in the basic diagram. There is no intersection between foreigner and Canadian. So foreigner and Canadian, there is no intersection. Now we look at whether this new diagram it exists when we check with the statements. We'll try that. Some people are nice. Well, some people are nice. That's correct. There is an intersection between people and nice. And some foreigners are people. Well, some foreigners are people. Definitely, some foreigners are people. And no foreigner is a Canadian. No foreigner is a Canadian. That's correct. So this new diagram exists. If the new diagram exists, a new diagram is based on, or it's drawn based on the negated conclusion, all foreigners are nice. So this negated conclusion, all foreigners are nice, is valid because the diagram exists. If it is valid, then original conclusion must be invalid for the new diagram. Original conclusion is valid for the basic diagram. It must be invalid for the new diagram. So if it is invalid for at least one diagram, then it doesn't follow. So conclusion number 3 doesn't follow. Alright, so we look at the conclusion number 4. When we look at conclusion number 4, we don't need this new diagram. We look at the conclusion number 4 with the basic diagram first. And if it is required, we will draw a new diagram for the conclusion number 4. The new diagram which is drawn for conclusion number 3 cannot be used for conclusion number 4. When we check the conclusion number 4 first, we will check it with the basic diagram. Okay, so let's get rid of this unwanted diagram here. Now, let's try this one here. Some people are not Canadians. Look at this, some people, they are not Canadians. That's correct. If you take some people from here, they are not Canadians. So it is valid. So conclusion number 4 is valid. Conclusion number 4 is valid. At the same time, look at conclusion number 4. What's the peculiarity? Conclusion number 4 is what? It's a negative conclusion. If it's a negative conclusion, we have to negate it. When you negate it, what do you get? Some not. Some not, when you negate it, what? That become all. All people are Canadians. Negation of some not is all. Subject, people, predicate, Canadians, that would be same. So some people are Canadians. Some people are Canadians. When you draw the new diagram, some people must be Canadians. Some people. Well, not some people, all people. All people are Canadians. And we have people and Canadians here. People and Canadians here. Now what is next? We need missing terms. Which are the missing terms? Foreigners, and we have nice as well. So we know that foreigners are intersecting with the people. So foreigners must be intersecting with the people. At the same time, we have nice is intersecting with the people. So nice must be intersecting with the people. And now we look at this new diagram with the given statements. So given statements, these are the given statements. Some people are nice. Well, some people are nice. That's correct. And some foreigners are people. Well, some foreigners are people. That's perfectly all right. No foreigner is a Canadian. So this case, foreigner, Canadian, there is an intersection between foreigner and Canadian. So statement says no foreigner is a Canadian. That means this new diagram doesn't exist. The reason for that, the statement says no foreigner is a Canadian. In the new diagram, some foreigners are Canadians. This is the Canadian circle. You see this? This is the Canadian circle. So some foreigners are intersecting with the Canadian circle. Why the foreigners are intersecting with the Canadian circle? Because some foreigners must intersect with the people. Foreigners must intersect with the people as it is in the basic diagram. So this diagram contradicts with the given statement. So if it is contradicts with the given statement, that means it doesn't follow. So the diagram doesn't follow means the diagram is drawn based on the negated conclusion. So negated conclusion is invalid. If negated conclusion is invalid, the original conclusion is again valid for the new diagram as well. So the original conclusion is valid for the basic diagram and it's valid for the new diagram with the maximum overlap. So it is valid for the minimum overlap and this is valid for the maximum overlap. That means it is valid for all other diagrams in between. So ultimately conclusion 4 follows. So it follows conclusion 4. So what is the answer here? Only 4 follows. And 3 and 4 follow? No, it doesn't work. And both 2 and 3 follow? Both 2 and 3? Well, 2 doesn't follow, 3 doesn't follow. No. And 4 and 1? Well, 4 follows but 1 doesn't follow. So the answer what we have is only 4. That's the answer. So every time when we get a question, we start from what? The basic diagram, correct? So here we have statements. We'll start from the basic diagram. So what are the statements? Some coats are dogs. All coats are clocks. So we'll start from all coats are clocks. All coats are clocks. And some coats are dogs. Some coats are dogs. Dogs. And well, no frog is a clock. So clock and this is clock and frog, there is no intersection. No, clock is a frog. So this is what you have. That's a basic diagram. Now look at the conclusions. Conclusion number 1. No frog is a dog. No frog is a dog. That's correct. However, this is negative. If it is negative, if a negative conclusion is valid, what do you have to do? You have to negate it, right? So when you negate it, what do you get? Some frogs are dogs or some frog is a dog. So some frogs are dogs. When you draw a new diagram with a negative conclusion, some frogs are dogs, some frogs must be intersecting with the dogs, right? So frog must be intersecting with the dogs. Is there any restriction for frogs to intersect with the dogs? Any of the statements says that no dogs are frogs or no frogs are dogs. No such statement says. So that means frogs can intersect with the dogs, right? So that case, the new diagram, if you draw a new diagram, frogs are intersecting with the dogs, that new diagram exists. If the new diagram exists, original conclusion doesn't follow. So actually in this case, we are not really drawing the new diagram. You have to visualize the new diagram. So exam point of view, this is what we do. We don't need to draw a new diagram. We visualize the new diagram. Now second one, no frog is a coat. No frog is a coat. That's correct. No frog is a coat. However, again this is negative. If it is negative, negative is valid, we have to negate it. So some frogs are coats. Some frogs must be coats. So when we draw a new diagram, when these frogs are intersecting with the coats, what happens? When the frogs intersect with the coats, coats are inside clogs. So when the frogs try to intersect with the coats, the frogs must intersect with the clogs as well. So it clearly says that frogs cannot intersect with the clogs. So that case, when you draw a new diagram, frogs are intersecting with the coats, that new diagram doesn't exist. That means original conclusion follows. So that's what it is. Original conclusion follows. Number 3. Some dogs are not frogs. Some dogs, when you look at that, some dogs, they are not frogs. That's correct. However, it's negative. If it is negative, we have to negate it. So what you get is all dogs are frogs. All dogs. That means all dogs inside the frogs. If these dogs go inside frogs, what happens? Let's say these dogs are here, dogs. They are inside frogs. Then dogs must be intersecting with the coats, correct? Then you see that this is how the new diagram, what? The coats comes over here because coats must be intersecting with the dogs. At the same time, the coats are inside what? Clogs. So then clogs must be here as well. So these are clogs. That case, ultimately the clogs are intersecting with what? Frogs. The clogs cannot intersect with the frogs. So that means, well, the new diagram doesn't exist. If the new diagram doesn't exist, original conclusion follows. New diagram doesn't exist, original conclusion follows. So that is what it is. So we get rid of this new diagram part. We just need the basic conclusion for, basic diagram for next conclusion. So this one follows, correct? So negative conclusion, it's valid. We negated it. New diagram doesn't exist. Original conclusion follows. Now we go for 4. Some dogs are frogs. Some dogs that are frogs. Some dogs are frogs. Well, there is no intersection between dogs and frogs. Some dogs are frogs. It is invalid, so it doesn't follow. Ultimately, what do you get here? Conclusion number 2 and conclusion number 3, those two conclusions follow. So conclusion number 2 and 3. 2 and 3 follow. And conclusion number 1 and 4 doesn't follow. Okay, that's fine. So 2 and 3. So 2 and 3, this is what it is. And next one we go for 39. So let's see what happens here. Some trucks are bikes, some bikes are scooters. Well, don't confuse. The statement says some trucks are bikes. No need to worry about it. Some trucks are bikes, okay, let it be there. So we'll draw the diagram based on that. Some trucks are bikes. And some bikes are scooters. Some trucks are bikes, some bikes are scooters. Now, conclusion number 1. Some trucks are scooters. Well, some trucks, are they scooters? No, not at all. Trucks and scooters, there is no intersection, so it is positive conclusion, invalid, doesn't follow. All bikes are scooters. All bikes are scooters. Well, some bikes are scooters. Not all the bikes are scooters. So that means it is invalid, doesn't follow. Now here what happens? Both conclusions do not follow. If both conclusions do not follow, our answer is neither 1 nor 2. Now 40. All rays are sun. So let's take a look at that. All rays are sun. Some sun are white. All rays are sun. Some sun are white. Some moon is rays. So there is an intersection between ray and the moon. Now conclusion. No rays are white. Look at that. Ray and white. There is no intersection between ray and white. So no rays are white, that's correct. So it's valid. If it is valid, well, this is negative. So we have to negate it. When you negate it, that becomes some. Some rays are white. So when you negate it, that becomes some rays are white. Some rays are white. When you draw a new diagram, rays must be intersecting with a white. Is there any kind of restriction for rays to intersect with a white? See that. Rays and white, there is no statement says ray cannot be white or white cannot be rays. Usually, if there is such a statement, it usually says no rays are white or no white are rays. But we don't have such a statement. That means a ray can intersect with a white. So new diagram exists, original conclusion doesn't follow. Now, number 2, some white are rays. Some white are rays. Well, look at this. White and rays. There is no intersection between white and rays. So some white are rays. It is what? It is invalid, doesn't follow. Number 3, some sun is moon. Some sun. Look at that. This is the sun circle. So some sun is moon. That's correct. Sun and moon, there is an intersection. So some sun is moon. That's correct. So ultimately, when you look at the answer choice, only 3 follows. Yes, we have the answer choice. Only 3 follows. None follows is not correct. Now what we have is either 2 or 3, and 1 follows. 1 doesn't follow, so we don't have such an answer. It's not correct. Either 1 or 2 and 3 follow. So this case, only 3 follow, and this case 3 follow, and at the same time we have either 1 or 2. Either 1 or 2, at what kind of situation you have either or kind of conclusion. This case, look at these 2 conclusions. Don't look at 3, we don't need that 3. 3 already follows the conclusion, so we don't look at that. Then these 2 conclusions, they do not follow. When you look at a pair of 2 conclusions which do not follow, if one is no and other one is some, what is the peculiarity of no and some? These are negated pairs. Negation of no is some. So these are negated pairs, both do not follow. Now we have subject. Subject means first term. Here the subject is predicate. So we have race, and we have predicate of this second term as the first term here. So subject, predicate, subject. That's what it is. So if you have 3 conditions, if both conclusions do not follow, these 2 are negated pairs, subject is predicate and predicate is subject, then what is that? That case, these are either or pair. So ultimately, either 1 or 2 and 3, anyhow 3 follows. So either 1 or 2 and 3 follows. Remember what I said. We'll go back to question number 36, I guess. Yeah, 36. That is what I said. This is this case. What was the answer for this question? Only 4 follows, right? So only 4 follows. That's correct. At the same time, you look at these conclusions here. This is some. This is some. This is no. Any 2 conclusions do not follow. This case, 3 conclusions do not follow. If any 2 conclusions do not follow, we need to look at the possibility of either or. So this case, is there any either or pair between these 3 conclusions? Let me mark those 3 conclusions here. Any either or pair between these 3. If you take 1 and 2, these both are some conclusions, right? So between these 2 some conclusions, we cannot have either or pair. For either or pair, we need to have what? Negated pairs. So 1 and 2 doesn't work. 1 and 3. So some willow are big, no willow is big. See that? Here it is some, here it's no. Willow, subject is subject, predicate is predicate. And both conclusions do not follow. These are negated pairs. So there is an either or possibility between 1 and 3. So the answer for this question, the exact answer for this question is only 4, anyhow 4 follows, only 4 and either 1 or 3. So we don't have such an answer choice here, either 1 or 3. We don't have either 1 or 3. Only 4 and either 1 or 3, we don't have such an answer choice. But if you had such an answer choice, that would have been the perfect answer for this question. So in this case, we don't have such an answer choice. Among the given answer choice, only 4 follows. That would be the best answer we have. So that answer we have marked here. Now in this case, we have, well, the fourth conclusion follows. And is there any either or pair between 1, 2 and 3? So look at 1, 2, 3. Any either or pair here? Check it out. So 1 and 2 both do not follow. Some and some. Some and some are not negated pairs. Some and no, it's negated pair. In this case, some and some, not negated pairs. So 1 and 2 doesn't work. 1 and 3. Well, it is some and some not. Some and some not are not negated pairs. It is no and some are negated pairs. Or otherwise, all and some not. Well, all and some not or some and no. In this case, 1 and 2 both are some. 1 and 3, it is some and some not. Some and some not are negative pairs. They are not negative pairs. Well, it's all and some not. It's negative pair. In this case, some and some not, it's not a negative pair. Next possibility, 2 and 3. 2 and 3, it is some and again 3 is some not. So again, some and some not, they are not negated pairs. So which are the negated pairs? Some and no, all and some not. This case, what you get is some and some or some and some not, and this case some and some not as well. So we don't have negated pairs. So there is no possibility of either or between 1, 2 and 3. So it doesn't work. So no need to worry about it. The answer is only 4 follows. So we have already proved that 4 follows here. So 4. Now this case, we have 2 and 3 conclusions, 2 and 3 follow, but 1 and 4 doesn't follow. Is there any possibility of either or pair between 1 and 4? For either or pair, both do not follow. That's correct. 1 and 4 both do not follow. One is no, the other one is some. That is perfectly all right. So they are negated pairs. Now frog is here, and dog is here. So that means this is either 1 or 4. So the best answer for this question, only 2 and 3. Along with that, we have either 1 or 4 follow. Either 1 or 4, we don't have such an answer choice given here. So among the best answer choices, we took as 2 and 3 follows. So that's the answer we had earlier. So that's the same answer. We stick on to that answer since we don't have any other better answer choice. Now 39, well, both conclusions do not follow. Here one is some, the other one is all. Some and all, they are not negated pairs. Negated pairs are some not and all. So in this case, these are not negated pairs. That means they are not either or pair. So there is no possibility of either or. What we have is neither nor. Neither nor means both do not follow. This case, we have discussed that either 1 or 2 and 3 follows. 3 anyhow, 3 follows, that is confirmed. And along with that, we have either 1 or 3. Either 1 or 3 means either 1, if 1 follows, 2 doesn't follow. Either 1 or 2 means if 1 follows, then 2 doesn't follow. If 2 follows, then 1 doesn't follow. But 3, always it follows. We have checked that. 3 follows. Now next one, this is what, we'll take a look at this one. No door is dog. All dogs are cats. All dogs are cats. All dogs are cats. So these are dogs. And what it says, no door is dog. Door and dog, there is no intersection. So that's a basic type. Now we look at the conclusions. No door is a cat. No door is a cat. That's correct. There's no intersection between door and cat. However, it's negative. So if it is negative, we have to negate. Some doors are cats. Some doors, cats. When we negate and when you draw the new diagram, some doors are cats. Door and cat can intersect, but door and dog cannot intersect. So that means new diagram exists, original conclusion doesn't follow. Number 2, no cat is door. Well, no cat is door. That's correct. No cat is door. However, it's negative. So valid but negative. So we need to negate it. When you negate it, some cats are doors. Some cats are doors. So some of the cats must be intersecting with the doors. So the cats are intersecting with the doors. It's perfectly all right. Cat can intersect with the doors. However, dog cannot intersect with the doors. So cat can intersect with the doors. So new diagram exists, original conclusion doesn't follow. Now some cats are dogs. Well, some cats, are they dogs? All dogs are cats, so some cats are dogs. That's correct. And all the cats are dogs. All the cats, not really. Some of the cats are dogs, but all the cats are not dogs. So this one doesn't follow. Now we have 3 conclusions do not follow. Is there any possibility of either or between 1, 2 and 4? You don't need to consider 3 because it already follows. When you consider either or pair, we pick only the conclusions which do not follow. So that case 1, 3 and 4. So 1 and 2, they are not negated pairs. 1 and 4, no and all. No and all are not negated pairs. No and some are negated pairs. So 1 and 4 doesn't work. Next thing 2. 2 and 4, well, it is no and all. Doesn't work. So there is no possibility of either or pair here. The final answer would be some cats are dogs. Only conclusion 3 follows. That's the answer. Only 3 follows. We'll go for the next one here. Yeah, this one is we have done earlier. These are some of the simple basic questions. We have done that earlier. So now if we move forward, this is another set of questions. Directions for questions 46 to 50. Read the given information carefully and answer the questions. So this is some like a circular arrangement. 8 persons L, M, N, P, Q, R, S and T are sitting equidistant on a round table conference facing the center. So we'll take a look at how this arrangement can be made. How many persons? 8 persons. So 1, 2, 3, 4, 5, 6, 7, 8. And R sits between L and S. So R sits between L and S. So R, L, R, S or S, R, L. S, who is the neighbor of Q, sits 3 places to the right of T. So let's say T is here. T is facing the center. That means this is the right hand side of T. And well, S, who is the neighbor of Q, sits 3 places to the right of T. 3 places to the right of T, 1, 2, 3. S is here. And Q is the neighbor of S. So Q could be either here or Q could be here. There are 2 possibilities. Now what we are looking for, Q sits 2 places to the right of T. So T, 2 places to the right of T, Q. So Q must be here. So this position is confirmed. Now M sits 3 places to the left of R. So where is R? We need to find out. But what we know is LRS or SRL. So S is already here. So LRS, one of the possibility, or SRL, doesn't matter. So R is between. So R is adjacent to S and L. So R must be adjacent to S and R must be adjacent to L. Now M sits 3 places to the left of R. So which is the left hand side of R? This is the left hand side. R is facing this direction. This is the left hand side of R. This is the right hand side of R. So 1, 2, 3. So M sits 3 places to the left of R. M sits 3 places to the left of R. So M is here. And it's clearly mentioned that all of these people are facing the center. Now, who are the people missing here? Among the arrangement, we have L is here, we have M here, N is not here, P is not here, Q is here, R is here, S, T. So N and P are missing. So where is N, where is P? It is not specifically mentioned where is N and P. So that means N can be here, P can be here, or there is another possibility, N is here or P could be here. There are two possibilities for N and P. So ultimately there are two arrangements. One arrangement with N here and P here, another arrangement with N here and P here. Look at the questions. Who sits diagonally opposite to M? So M is here. Who sits diagonally opposite? That's L. So L is the answer. Now we go for question number 47. 47, it's exact same question. That means exact same descriptions given over here. That means this question is based on the previous arrangement, right? So questions 46 to 50, same arrangement, questions are different. Now 47, between which two persons does S sits? So well, S sits between R and Q, or Q and R. So this is R and Q. Answer choice 3. Now who sits diagonally opposite to S? So we'll take a look at that diagram. Diagonally opposite to S is either P or N. So we are not sure about that. Either P or N. So well, N or P. That means the answer is either N or P. That's the best answer. Now we have 49. Which one of the following is Q's neighbor? Q's neighbor. Well, Q's neighbors are S and M. S or M. Which one of the following is Q's neighbor? S is the neighbor of Q. M is not among the answer choices, so S is the neighbor of M. S is the neighbor of Q. Now, who sits immediately to the left of L? Immediate to the left of L, who's that? Immediate left of L. L is facing this direction. Immediate left, it's R. So who is immediate left of L? That's R. So we'll go for the question 50. Who sits immediate to the left of L? That's R. So these are the questions for the day we have. So this pretty much we have done classification type questions. And the last set of questions we have done, it's pretty much seating arrangement type questions, circular arrangement, and in between we have done a number of questions from syllogism. So do your best, practice as many questions as you can, and especially in syllogism, check out those questions with negative conclusion which is valid for the basic diagram. So negative conclusion which is valid for the basic diagram, what you have to do is negate the conclusion, draw a new diagram and check whether this new diagram exists or not. So it's a pleasure working with you guys. See you next time. Thanks for watching.